Okay, review of factoring methods pre 8.1. This is technically video number 2. Okay, let's continue where we left off. On this question, we have a difference of two perfect cube terms, or perfect square terms, two square terms. We have a 9, that's a perfect square number, a 25, that's a perfect square number. There's a minus sign between them. So maybe, just maybe, you could square root both of them and plug them into your answer format. What is the square root of 9x squared? That would be 3x, right? The square root of 9 is 3, and the square root of x squared is x. So we have a 3x as the first part of the binomial, the 3x is the first part of the binomial. And then what's the square root of 25? That's 5. So we put a 5 right there and a 5 right there. Now, in order for the middle term to not be there, right? This is not a trinomial, it's a binomial. You have your ax squared, there is no bx, and you have a c. In order for the bx term to be nothing, well, then this has to be a plus and this has to be a minus. I mean, not only that, and it doesn't matter which one you put, if you put a minus here or a plus there, or the way I wrote it right here, this times this has to be a negative 25. That means the signs have to be different. Anyways, that is the correct answer right there. There's no need to double check because we do know that those middle terms will cancel out. So this is a difference of two squares. It's a perfect square binomial. You just square root it, plug it in, 1 plus, 1 minus, you're done. Let's move on. On this question, they want us to also factor, but the first type of factoring method that we learned was factoring out the GCF. That's the first type of factoring method that we are always supposed to try. So could you pull out an 8 from here and there? No, you cannot, right? But you could at least pull out a 2, but try to pull out the greatest common factor, the GCF. That would be, 2, that's it. It can't be 4, so 2 is the absolute greatest common factor that you could pull out of there from each of those. So when you pull out a 2, you will have a 4x squared left over. And when you pull out a 2, 2 times what gets you back to negative 18? 2 times negative 9 will get you back to a negative 18. Okay, so now when we look at the inside, when we look at the inside of the parenthesis, we have a perfect square binomial, a difference of two perfect square terms. So we could continue factoring that by square rooting 4x squared, putting it right there, and square rooting 9 and putting it right there. So square root both of these and put them there, square root both of these, put them there. So what is the square root of 4x squared? That's 2x. And what is the square root of 9? That's 3. And of course, in order to get 3 times 3 to give you a negative 9, one has to be positive and one has to be negative. And don't forget about that outside 2 that comes down. This is the completely factored form, and that's all there is to it. Let's move on. Oh yeah, this one's fun. Why is it fun? Well, because the a value is not 1, right? It's not just the x squared where you think what times what is this one, that if you add together is this one. We actually have a number out here, okay? So when you have a number out here, you have to use that multi-step process, but I did show you that shortcut, and we're gonna use that shortcut. Step 1, when your a value is not 1, is to multiply a times c, and that is, of course, 10 times 3. The a value is 10, and the c value is 3, so that is the answer 30. Okay, so step 1, the answer is 30. Step 2, make a list of the multiples of that answer. So we're going to go 1 times 30, 2 times 15, 3 times 10, 4 times, how about 5? 5 times 6, yep, and that's about it. Those are the only multiplication combos that work to give you 30 besides changing signs and changing the order. Anyhow, which of these pair of numbers combines together to give you the middle value, negative 17? Well, if I combine 30 and 1, that's 31, that's not 31. If I combine 15 and 2, that's 17. That's not exactly 17, it's negative 17. So I have the right number 17, but just the wrong sign. So over here I have the right numbers, just the wrong signs. So this is the right pair of numbers, but I'm going to change both of those signs to a negative 2 and a negative 15. Now, the third step is to do your factored form format, and you put an 8x right here and an 8x right there. What is your a? It's actually 10, okay? So we're going to put 10x and 10x. And then we think, what about these blank spots? Well, the pair of numbers from step 2 go right into those blank spots. So we have a minus 2 and also a minus 15. So that's step 3. The final step is to magically reduce, magically divide each of these binomials by whatever you can, the maximum value that is. So the 10x and the 2, you could divide both of those by 2, and it would give us the final answer over here. The first binomial will be a 5x minus, and the second term would be a 1 right there, minus 1. And then the second binomial, we could magically divide this by 3, right? No, not by 3, by 5. Okay, and you know what? I shouldn't have put, I want to put it in a cloud, both of those. Let me see. Put it in a cloud, dividing by 2, this one divided by 5, giving us a final answer of 2x minus 3. And that's it. Again, this is the magically divide by 2, magically divide by 5, and you get that final answer. If you wanted to double check it, distribute, combine like terms, and you should get back to the original. Anyways, that's your answer. That's what you need to type in for full credit. Let's move on. Okay, factor this one. Oh man, I miss these guys. What do I mean by these guys? Well, when you don't have a number, that's the easiest type of factoring, because all you do is set up the x and think what times what is a c value that if you combine together is the b value. So what times what is negative 12? I would say make a list. Negative 1 times 12, negative 2 times 6, negative 3 times 4. Now, which of those pair of numbers combines together to give you the middle value, negative 7? Well, negative 3 plus 4 is 1, not negative 7. That didn't work. 6 minus 2 is 4, not negative 7. That didn't work. 12 minus 1 is 11. That's not 11. So it doesn't work. You cannot factor it. And when you cannot factor something, you simply say not factorable. That means that you are not able to factor it, okay? So you could just type in NF and you're good. Let's move on. Oh yeah, I love these. Why do I love these? Because there's no number in the front, which means you could jump right in to the factored form format, parentheses, XX, and simply think what times what is your C value that if you combine together is your B value. Let's make a list of the multiples of negative 12, that C value. How could you get negative 12? Negative 1 times 12, negative 2 times 6, negative 3 times 4, and that's about it. Which pair of numbers combines together to give us the middle value, negative 4? Well, 12 minus 1 is 11. That's not 11. 6 minus 2 is 4. And that is a 4, but I want it to be a negative 4. So I have the right number, just the wrong sign. I have the right numbers, just the wrong signs. So we're going to change this to a plus 2, that to a minus 6, and that's the combo I want. Simply plug that in, plus 2 right there, minus 6 right there, and you are done. You have factored it. Let's move on. On this question, they're asking us to state the GCF, not to factor it or factor it completely, but just what is the GCF? And what is GCF? It's the greatest common factor. You don't want just any common factor. Like I could see that there's the multiple of 2, multiple of 2, multiple of 2. So yeah, 2 is a common factor, but it's not the greatest common factor. So let's think this through. Yes, you could pull out a 2 from the 16, from the 32, and the 12. But could you pull out maybe a 4? And the answer is yes, right? 4 will go into 16. 32 is divisible by 4, and 12 is divisible by 4. And that's, I mean, if you try other bigger numbers like 6, it won't work. 8, it won't work. So yeah, 4 is the greatest multiple that you could pull out. And then in addition to that, so like, let's pretend that we're factoring, okay? You could pull out a 4, but you could also pull out x's. You see, there's 5 x's here, 3 x's there, 7 x's there. Question is, what's the greatest amount of x's you could pull out of all 3 terms? And that would be x to the 3rd. So your GCF is 4x to the 3rd, right? And when you look for that multiple choice answer, none of these are the GCF. So you would select that one. None of these are the GCF because the GCF is 4x to the 3rd. Let's move on. Finally, at the last question of this second video, again, the A value is not 1, so you could jump right into the factored form format XX, and you could simply think what times what is your C value that if you combine together is your B value. Let's make a list. What times what is 48? Well, 1 times 48, 2 times 24, 3 times 16, 4 times 12, 5 doesn't work, 6 times 8 is 48, and that's about it. 7 doesn't work, and 8 will be back to 8 times 6, which is 6 times 8. So these are all the pair of numbers that you could possibly multiply to get 48, besides changing signs or changing the order. But anyways, which of these pair of numbers combines together to give us a middle value 14? I could clearly see that 4 plus 12 is 14. There is no need to change any signs. That is a positive 4 and a positive 12. And we are done.